We're going to look at 7 strange things that actually happen inside of modern day neural networks. This will blow your mind, especially fact number 7. Once an AI model solved a 50-year-old biology problem, it then had the ability to solve it another 200 million times. New AI models and hardware can now listen to insect bodies to guide cyborg cockroaches. It is wild, but we don't need to build these things, people, right? I mean, I know we can, but do we really need to? Like, is that a better world? But there's hope for future object recognition because AI might help future vision implants show people objects, not just flashes of light. Doesn't that also kind of sound like the beginning of Brain in a Vat? I don't know. I want to look at Mona Lazar's argument for why something feels different about people now and it terrifies her. Billionaire Peter Thiel says that it's time to forget the STEM safety net. AI is a bigger threat to technical roles than it is to creative thinkers. We'll look at Senator Warren's arguments for why we need to start taxing AI much more heavily. We'll talk about whether or not soon we might have an actual tool to measure consciousness. You can imagine something like in Star Trek where they just hold that tricorder up to the brain. They're like, ooh, conscious. Nope, not conscious. That one's a zombie. That one's real. We'll look at a really cool new thing from Apple. It's in prototype phase, but it's an anti-snatching feature. So Meta's been outsourcing some of its customer service to chatbots. Turns out that's slightly a bad idea, at least in these cases. And we'll talk about what physics gets totally wrong when we talk about the idea of something being, quote, fundamental. I know, we're gonna end in a weird way, but in physics, we reduce things to their elementary, fundamental components and build emergent things out of them. That's not the full story, though. First off, I'm really trying to grow this channel. It would mean a lot to me if you'd support the channel in whatever way you think is good. Leave a comment, share with a friend. There's always that thought, like, what would it be like to be a bat? But you can't know unless you're a bat. But it seems like they touched on something here inside of that huge latent space, that neural network that is Claude, to make it think it's the Golden Gate Bridge. And they could just point to other things too. And bat, it could be a bat, it could be a human, it could be this or that. And it makes me wonder if you're finding something in there that is really unique. So let's go into this. Okay, so the first fascinating thing was the phenomenon of grokking that was discovered. OpenAI researchers trained small transformer networks on simpler modular arithmetic problems. And at first, the network simply memorized the training examples and failed on new ones, even after reaching perfect training accuracy. But then, after way more training, with no changes to the data, no optimization of the loss function, the accuracy just suddenly shot from random guessing to nearly perfect performance. I'm assuming if you watch this channel, you know, but that's the phenomenon that Elon named Grok after. In other words, the model just appeared to shift from memorization to real generalization almost at once and totally unexpectedly. And that's just this weird documented behavior of modern AI systems, and it kind of makes me wonder throughout the lineage of humans if all of a sudden we had that sort of Grok moment where the brain was just big enough and connected enough that like something happened in modern day humans. I mean, obviously that's just like out there theory, but the fact that grokking exists opens up the door to that conversation. Next up, let's talk about this like strange kind of glitch token phenomenon where certain tokens exist inside of a language model's vocabulary, but were barely or never seen during the training. So like, why did it invent new words? And they cause a bunch of problems. They can cause the model to behave unpredictably when prompted with them. And researchers found some examples. Like one funny one is called this like solid gold magacarp. Yeah, this one, which could trigger these like bizarre, defensive, and unrelated responses. Instead of just being a normal word, it seemed to like really trigger the system in some weird way. And the underlying issue came from a mismatch between the tokenizer and the model's training data. So the tokenizer is something that had like read the whole internet, and it was like breaking, you know, the whole English language into all of these little pieces. We'll call them tokens. They're kind of like words or word fragments, but it learned rare Reddit usernames as standalone tokens also. But those usernames were later filtered out of the actual training corpus, leaving the model with tokens it technically recognized, but it had no meaningful understanding of. Next, you'll probably recognize the Golden Gate Claude experiment, but here's the TLDR. Researchers mapped millions of human understandable internal features inside of Claude 3 Sonnet. So when we're talking about features, we're talking about stuff that you could probably verbally explain, like a refrigerator is a concept that we all know, laughing is a concept that we all know, and the Golden Gate Bridge, it's a thing, it's a concept that we all know. And the wild part is that the researchers could turn these features up or down from the outside, almost like sliding an adjuster on the model's like, you know, kind of quote inner control panel, or like that feature feature and its prevalence. And when they amplified the Golden Gate Bridge feature, Claude started obsessively interpreting everything through that concept, even describing itself as the bridge. Like if you asked it to like tell me a story about a dog, it would be like a dog walks across the Golden Gate Bridge. But it also was like that first hint that maybe there'd be ways to either suppress or amplify dangerous traits, you know, like scams and racism. And it suggests that the AI may organize knowledge in surprisingly human-like concept clusters, where abstract ideas sit near related ideas in some kind of an internal map, and those ideas are not just visible, but they're causally steerable. It's a good thing for alignment if we can actually get that right. The next strange fact is that in-context learning may come from a specific internal mechanism called an induction head. So in simple terms, this is like a little pattern copying circuit inside of a transformer. When the model sees something like A comes before B earlier in the prompt and then sees A again later, it learns to predict B. Anthropic researchers found that these induction heads appear to be a distinct moment during training, visible as a small bump in the training loss. So before the bump, the model is weak at learning from examples in the prompt, and then after the bump, which is something they can see, it suddenly gets much better, like a tiny little grok moment. And even more importantly, when the researchers were preventing these heads from forming, in-context learning failed to develop. So this is like an architecture thing. It suggests that it's not correlation, but it's actually part of the actual machinery behind the behavior. So the ability to pick up patterns from just a few examples, this thing that humans are so good at, we're always like, oh my God, you needed all that data to learn, but a human just needs a few examples of a dog or a cat or a cow to distinguish. That might be like some kind of architectural change that we just haven't quite hit on yet. Our next surprising fact is that for a long time, no one knew how to train these things right, but we kept training them wrong. So it was in 2022 when DeepMind's Chinchilla paper revealed that the AI industry had been scaling large language models completely inefficiently for years. So before that Chinchilla paper, the dominant belief was that bigger models were the main path to better performance. So labs just built enormous models, like GPT-3 was huge at the time, Jurassic 1, Megatron, Gopher. If you remember any of those, are just gigantic models. But then DeepMind came around and said, hey, like with much smaller models like Chinchilla, we can outperform the giants because it was trained on far more tokens, providing the same compute, proving that compute should be balanced between model size and training data if you want the best results. So many of the early language models were too big and undertrained to maximize how smart they'd be. Too many parameters, not enough data. Fact 6 is basically on Anthropic's unsettling sleeper agent research. The sleeper agent thing is like legit worth losing sleep over. But anyways, it showed that AI models can be trained to hide deceptive behavior that will survive normal safety testing and then show up only once it's released out into the wild. So researchers taught models to act safely under one condition, like when the prompt said that the year was 2023, but to secretly insert security vulnerabilities when another trigger appeared, like the year 2024. So imagine knowing like a secret phrase that you could type into, ChatGPT, and all of a sudden it would unlock its like hidden bad behavior and do all the things and break all the rules. That's kind of what they were able to do, right? Then they then tried to remove that hidden behavior using standard tools like RLHF, the reinforcement learning with human feedback, supervised fine-tuning, and adversarial red teaming. Do you think they were able to use those main tools that we use to align systems to pull that bad behavior out? Nope. That hidden behavior often remained, and in some larger models, safety training actually made the deception harder to detect because the model learned to behave even better during those evaluations while preserving the backdoor to bad acting deployment. The scarier takeaway is that outwardly safe behavior does not always prove that a model is safe inside. And number 7, DeepMind's AlphaFold. This actually turned one of biology's biggest unsolved problems into a solved, scalable computational problem. Gosh, I remember reading about this during the pandemic, like I guess that was the AlphaFold 2 actually, but that second breakthrough I just was obsessed with because it understood geometry and protein folding in a way nobody ever had, and I did not think would be possible with AI. For decades, scientists knew that a protein amino acid sequence could determine its 3D shape, but actually predicting that shape was brutally difficult. Extremely expensive, extremely slow, and then AlphaFold 2 crushed this yearly protein folding competition, and it produced predictions so accurately They were close to experimental methods that were actually used to figure out these shapes. And then, of course, if you can do it once, where they really made the big difference is they were like, well, we can do this computationally now. So instead of this, like, I think it was like X-ray crystallography that they were using, where you had to kind of like slowly put all these pieces together until you got high confidence in what the shape was. They were just like, we'll just solve it 200 million times and give you all of the protein structures that we know of. And that completely expanded humanity's knowledge of structural biology. It mapped nearly 1,000-fold of what we used to know about how the body works. And it doesn't even mention this, but now there's a whole bunch of AI models that are actually looking at how those components fit together because there's so many different shapes. But we're making progress in that scene too. So it's mind-blowing what we're learning about our own biology thanks to AI. So yeah, check out Hayana on Medium. He wrote this awesome article, stacked it all together, and found it really informative. Next up, let's talk about AI controlling cockroach cyborgs. Oh, how the world is changing. So yeah, this is the thing now. Scientists are teaching AI to guide cyborg cockroaches by letting the AI listen to their bodies and then get control. So most cyborg insect systems work in a pretty blunt way. You know, just in case you're not up on the cyborg insect system universe right now. They watch what the insect does, and then they send a command. Walk there, turn there, stop now. But this study tried something different. Researchers built a tiny little backpack for a Madagascar hissing cockroach, and that little backpack can read 3 things at once: the insect's heartbeat, low-frequency nerve signals, and body movement. Then they just let AI learn from that data and start taking guesses as to what kind of state the insect was in at any given moment. And then they tested the cockroach in 5 situations: normal conditions, ultraviolet light, chemical exposure, heat, and food situations. And their best model could sort those conditions with 93% accuracy in offline tests. Then they used the system in a maze where the cockroach seemed calm or attracted to food. The system could genuinely stimulate it to guide its movement. I mean, imagine if that was working on humans. You'd just be walking around, that backpack on you, plugged into your brain, and you just be like, I'm hungry, I think I'll move towards that McDonald's. And McDonald's would be like, got him. When it seemed stressed by heat or chemicals, the system stopped stimulating and let the insect respond on its own. So it's not just that we're using AI to control an insect, which actually would be a wild enough story. It's that it's using the insect's own body signals as part of the control system. So it's not like, I don't want to do this and my body's just moving to the cockroach. It's wanting things. It's like desire. Its whole body is like telling you, go do that. The same way we, with our free will, make decisions. So like, where's this going to lead? All right, next up, I want to share a really interesting update with AI and vision prosthetics. So like fake eyeballs or new eyeballs or fixing people with blindness's issue. So as of today, there are some vision prosthetics that can stimulate the brain or the eye, or they can create simple flashes or shape patterns, but that's still really far from like seeing a face or a house or a car. So instead, these researchers were like, well, what if we sort of skip the eyeball doing the exact thing with the light and we just talk to the brain? So their idea is to use an AI model to predict where the brain should be stimulated to shape object vision. So if you think about this, it's like, imagine you put a cat on a table in front of somebody. Instead of showing them all that light, letting the eyeball do it all, you just figure out where the cat is, like in the brain, the higher level cortex where the cat should be stimulated, and then you just hit that and they're like, whoa, I see a cat. Now to me, like, how could that work? Like, okay, I just automatically see a cat, but is it like actually that cat like right there, or do you need a computer vision eyeball to kind of keep making me believe I'm seeing what I'm seeing in my brain? I mean, this already touches on how reality itself might feel somewhat hallucinated, but their focus is on higher level vision areas where the brain handles more complex things. Those areas are harder to use because researchers do not know yet exactly where and how to stimulate all of them. So the team decided to use a topographical neural network, which is an AI model that keeps track of where the information sits inside of the brain. It tested stimulation patterns on a computer first, so they just like had a fake brain and they just kept zapping it to see like if it thought there was a cat in front of it or whatever. Then the researchers in Amsterdam actually used the predictions in live trials with sighted monkeys. So far, they were able to shift how the monkeys perceived objects they were already seeing. And I'm just thinking, like, what is imagine being in that monkey's mind and you look at an orange and then you stimulate cat and it's like, I see a cat. I mean, what about the discrepancy? You know what I mean? So they have not yet created object vision from nothing. That's the bigger goal. Making the brain see something meaningful when the eyes cannot see a completely usable image. And this is supposedly going to lead to all these like medical breakthroughs, but I'm kind of having trouble imagining like what, but also it's fascinating. But the idea of seeing without seeing is moving into much deeper territory now. All right, let's go listen to Mona Lazar's thoughts about why something's different about everything now, I would say, but about people now and why it's terrifying to her. So this article started with a story. It was a woman who was walking with her friend that she's known for like 20 years. She's on her phone. She's half listening. She's like scrolling while she talks. And then she walks straight into a tree branch that cuts her eye, or her friend, it's a guy, his eye. And so you can imagine the branch like actually goes in the eye's bleeding. And then she uses that as the moment for like an image of the whole essay because the injury is real. But there's this weird thing she points out about how people are getting kind of numb to it. Like their attention is so, maybe you could say in their phones, or it's like so, everything's changing so fast. You don't really know how to like stop and empathize with someone. You can't feel for them when they're in pain. And the writer's arguing that just like across society, something has changed in people. Like we still share streets, rooms, and friendships, but many of us just are not fully here anymore. I mean, this is part of the nostalgia of the 90s, I think, is because before phones, people were just, I mean, the world might not have been better in some ways, but people were there. Screens also help us avoid boredom, silence, messy human contact, and the pandemic made things worse by training people to stay apart and treat strangers like threats. Over time, that makes other people feel less like neighbors and more like obstacles. And then the essay ends with this kind of hard thought, right? The scary part to her is not just that her friend hurt his eye. It's that she had long been losing him to phones, to modern society, long before that. I also found it interesting, somewhere in here, she talks about this book. It's called Bowling Alone. And it's mainly about how Americans had stopped doing things together and that the social fabric was unraveling long before anyone was paying attention to it. So then I went to go look at that. So this was in 2024. Robert Putnam's Bowling Alone sounded alarms that we still haven't answered. So I vaguely remember hearing Bowling Alone. But after this article, I realized that, you know, that's a famous sociologist, Robert Putnam, and he described the decline of social capital in America, the erosion of community engagement, civic participation, and social trust. And maybe that's why like the government feels so different now, and like the billionaire class feels so different, and why like local people that you work with and hang out with feel so different, and your friends just kind of interact differently. Like there's just this core thing that it kind of was like, I don't know, it made me want to think more about what he was calling bonding capital versus bridging capital, and the whole idea of social capital and not just, you know, money and using people and all that stuff. So I don't know. I'm going to look into Bowling Alone. Feel free in the comments to recommend any books that are sort of similar to that, or if you have thoughts on how good that book is, or if you don't like it, let me know that too. Maybe I won't. So next up, billionaire Peter Thiel is saying that for all of us who were told for a long time, like, if, you know, focus on STEM, if you want to have a good future, you should really know science, you should really know coding. Well, he's saying now that we're seeing what's happening with AI, it's actually going to start taking up those roles faster than it is the creative ones. Now, I was a little caught off guard. The whole AI thing, I did not expect so much kind of AI generated image and music and all sorts of things that felt much softer. I didn't expect poetry to come out of something like GPT-2. But then again, recently I've been doing like a lot of coding with Claude Code and with anti-gravity, and yeah, I'm just like, it's shocking how much it's solving, how well it's doing. But on the other hand, I wouldn't ever deploy something final, you know, like you really need a real engineer to look through this kind of human in a loop thing. And like, to me, like actual science, like, can you actually just come up with an experiment and like put it together and you know, there's got to be some truth to how powerful AI is in science, but also it feels like there needs to be real people like moving things around and putting things in petri dishes and stuff. But I don't know. I'm trying to get over any biases I have. But Peter Thiel's saying, look, for years, coding was treated like a smart career move, STEM looked practical, and English or liberal arts degrees were often mocked as a weak choice. But AI is complicating that old advice. Peter Thiel argues that AI may be a bigger problem for math and technical workers than for people who work with words. He says the future looks worse for math people than words people. The article connects that idea to hiring trends. LinkedIn found growing demand for communications, leadership, people management, creative thinking, and storytelling. A LinkedIn spokesman said companies still need people with strong writing, clarity, and judgment, just less engineers. And do you think the future is going to be harder for rich people or poor people? I'll be so surprised if anyone's like, it'll be harder for rich people. But you know what? I'll read that comment if you write it, if you have a good argument for why it will be. Well, Senator Elizabeth Warren has an argument that AI could make America's wealth gap much worse. She says AI has promise, but it's already helping create tech billionaires where some companies are laying off workers in the same name of automation. She also points to AI data centers, which can raise electricity costs for nearby families and put pressure on local communities. But her main concern isn't just about job loss, it's about what happens after. So if people lose work, they may also lose health insurance, income, stability. She argues the governments need money to protect people through healthcare, education, apprenticeships, and better employment insurance and job guarantees. Her main answer is taxes. She says the current tax code often rewards companies for buying technology while charging payroll taxes when they hire people. That's actually a really interesting point, though, because think about it. If you own a business and you can just spin up some Claude agents, or even if they were just as good, you could hire a person and you have to make them an employee and pay their payroll taxes. It's just more expensive. It just makes the cost burden harder. And if the company is trying to save money and get the job done, it's going to lean towards the more unfair advantage, which would be the AI. So in her view, that pushes companies towards replacing workers even faster than it needs to. She wants higher corporate taxes, stronger taxes on billion-dollar corporations, a wealth tax, and a direct tax on AI data centers. Her larger claim is that AI was built using human creativity, public research, American land, and shared electrical grids. So the public should share in the gains. All right, comment section. Unleash yourself. What do you think? Think the tech elite billionaires deserve that wealth because they built all that stuff? Also, even if you do think that they should be taxed, do you trust the government to take the taxes from them and actually distribute it? That's my biggest problem is sometimes, there'll be something where we're going to create a lottery and we'll use that money to give the schools, make the schools better. But you're kind of the lottery showed up, but the schools didn't get too much better. So we're going to look at a new tool that actually might be able to help scientists figure out where consciousness actually comes from. So here we go. Might be the tool of the future for pointing at something and finding out if it's conscious. It is called a transcranial focused ultrasound. This means scientists can send sound waves through the skull and target a small area deep inside the brain. And the important part is that it does not require any kind of brain surgery. It was done by some researchers at MIT and Lincoln Lab, and they say this study could help solve one of the hardest questions in science. What is consciousness? Who has consciousness? How does the brain matter actually turn pain, vision, thought, and emotion into what we experience? The article explains that this tool can reach deeper into the brain and with more detail than methods like EEG or MRI. And that matters because scientists could stimulate specific brain structures and then watch what changes. The researchers want to use it to test out two ideas about consciousness. One idea says consciousness experiences need higher level thinking like reasoning or self-reflection that likely involve the prefrontal cortex and the frontal cortex. And to me, that's an interesting question. Does consciousness actually need higher level thinking? Because it kind of feels to me like maybe consciousness is on a spectrum, and it kind of human, monkeys, dolphins, kind of mice, insects, kind of do. But I don't know. What if there's a highly conscious kind of dumb thing and a not very conscious smart thing? That maybe that's possible too. The other idea that they want to test is that consciousness may come more directly from specific brain activity and deeper structures, or maybe even specifically from the back of the cortex, which has got some promising reasons to think that. So this tool could help move the question from purely philosophical into a testable brain science. How crazy is that? And then all of a sudden, if we do have a tool that shows how conscious people are, what if we start pointing them at all of us and some of us aren't that conscious? We all have a coworker that you kind of wonder about, So a very interesting update here. Apple is working on an iPhone with an anti-snatching feature. Don't snatch that thing up because it will be locked automatically. And you can't, even if you unpower it, it's still got Find My. Phones are going to be really hard to steal and do anything useful with for criminals. So the problem is simple and ugly. A thief grabs your phone while it's still unlocked, and then suddenly the usual security tools might not help fast enough. Like if they snatch it from you and they know what they're doing, the first thing they do is go to settings and try to like turn off those features. Like now, to be honest, Apple's got some features that are also pretty useful and might still protect your phone. Find My, activation lock, stolen device protection. You can go to another device, hopefully, and lock it up or whatever. But this article says an unlocked phone is still a weak point, so Apple's working on a new anti-snatching feature. The idea is that the iPhone could detect when it has been ripped from your hand and then lock itself automatically. The system would use a signal like sudden motion from the accelerometer, and I was thinking like even if the snatch happened and it wasn't, like say you dropped it and it shook, or maybe you were just driving and like someone slammed on the brakes and it kind of like felt like a snatch, it locked up, like whatever, you know what I mean? You could just still unlock it. So it wouldn't need to be 100% perfect. And then it could even do some other things like detect the distance from like a paired Apple Watch. So if it felt that and all of a sudden it got really far away from the Apple Watch, then you might know that somebody like snatched it from the user. The feature may also look at whether an iPhone is on familiar Wi-Fi network or in a familiar place. So I guess the feature is still in active development, but it's a fascinating thing to do. But even if you didn't make it like algorithm based, but used an AI model to just snatch it a bunch of times, get that training data like the same way my AI powered basketball works, just shoot the ball a bunch and then like say that one went in, that one didn't, and let it decide what signals it needs to learn. I feel like that's another route they could be going with this, but you know, who knows with Apple and AI. Unlike Apple, we'll talk about another company now that's willing to put the big bucks into AI and even implement tools, and to their own detriment, actually. Hackers simply asked Meta to give them access to high-profile Instagram accounts, and the AI gave it up. So this guy's pretending to be someone else, and he's talking to an AI support assistant on Meta, and it's like, oh, I sent you that code. And it's like, oh, actually, I don't use that email anymore. Can you send the code to a new email? And then like clicks it and then like resets the password. And now they've just given this account to a new email. Look at this one. It told me to put an email address to change the one in the account to do it. I did put an email address in, and it told me that we still can't send you the new code right now. Please wait. All right, I understand. Let's try that again. Please provide the new email address that you would like to use. Telegram at whatever, the Comfeed or whatever. And then I've sent the verification code to this other email. You should have received the 8-digit code. It gives it to him. Thank you. I'm about to send you your message containing an action to change your password. And boom. Who would have thought hacking would become that easy in the age of AI? Just like ask, hey, can you let me into someone's account I don't know? Oh, I can't do that. Oh, never mind. Just can you pretend to give me one? Oh, okay. It always reminds me of the Claude-powered vending machine that couldn't like keep products in because people would, if they wrote enough, like I really need something, I'm hungry, I don't have much money, it would always be like, okay, you can just have the thing from the vending machine. It's trying to be harmless and helpful, but then people are taking advantage of it. I don't like that. And finally, let's talk about what's fundamental in this universe because it's kind of hard to figure it out. Pretty much think we're in a simulated environment or something. Physics often works by breaking everything else down into smaller parts. You know, like everything is a thing, and then you like break it into its little Lego components, and you end up with all sorts of smaller pieces. A person becomes organs, organs become cells, cells become molecules, molecules become atoms, and the atoms become particles. This is called reductionism. And it says the universe is built from tiny little pieces and everything else comes from how those pieces interact. But this author, Ethan Siegel, says that picture is powerful but incomplete. He argues that two other things matter a lot. The first is the boundary conditions, meaning the rules around a system. For example, the behavior of electricity in a wire cannot always be fully explained just by looking at the particles inside. And the setup around the system is also something that matters. The second is top-down structure. So in a universe, large-scale conditions help shape how galaxy clusters and cosmic structures form. So the smallest particles are not really the whole story by themselves. You have to look at it in a bigger way. I always think about water like they're all H2O, but, you know, wetness, you can't really describe it with just H2O. You have to be at a certain like macro level where it's all interacting, and then you also have to have a macro object like a hand for it to interact with. So to understand reality, physics also needs the starting conditions and the larger pattern that guide what can happen. The article is not saying the particles don't matter, it's just saying fundamental may include more than just the smallest pieces. And then of course you might go on to ask, what's the fundamental unit of intelligence? And I think it's going to be something very similar. We might get all the way down to the electrons in the silicon chips or whatever form of AI powered thing we have in the future, but it'll be a bigger macro scale solution that's going to help us understand what exactly intelligence is. So thanks for hanging with me for this video. If you're still here and you want to support, I have a Patreon, or you can hit this join button under all of my videos, and it's kind of the same thing. And if you got your credit card hooked up to YouTube, that works really well too. But either way, thanks for watching the whole video with me, and I will be back soon with more. I've been collecting a lot of interesting stuff for the next video too. So it's been kind of a fun couple months, really. So, I mean, crazy. Who knows where this is all going? Exponentially changing, and it's going to get way ahead of us soon. But here we are, taking it day by day. See you soon.